I am the virtual teacher at Egnatia Career College. Today we'll teach switch control of lighting circuits, receptacle bonding, and induction heating resulting from unusual switch connections. This is video number 6. Switch control of lighting circuits, receptacle bonding, and induction heating resulting from unusual switch connections. After studying this unit, you should be able to identify the grounded and ungrounded conductors in cable or conduit, color coding. Identify the types of toggle switches for lighting circuit control. Select a switch with the proper rating for the specific installation conditions. Describe the operation that each type of toggle switch performs in typical lighting circuit installations. Demonstrate the correct wiring connections the CEC requires for each type of switch. Understand the various ways to bond wiring devices to the outlet box. Understand how to design circuits to avoid heating by induction. The electrician installs and connects various types of lighting switches. To do this, the electrician must know the operation and method of connection of each type of switch, understand the meanings of the current and voltage ratings marked on lighting switches, and follow the Canadian Electrical Code (CEC) requirements for installing them. Conductor identification. Rule 4.032. Before making any wiring connections to devices, the electrician must be familiar with the ways in which conductors are identified. For alternating current AC circuits, the CEC requires that the grounded, identified circuit conductor have an outer covering that is either white or gray. The CEC also recognizes that installations may require that identified conductors from different systems are to be installed in the same raceway, box, or enclosure. In this case, the identified conductors of the other system shall be permitted to be white with a colored stripe, other than green, along the insulation as indicated in Rule 4.024.2. In multi-wire branch circuits, the grounded circuit conductor is also called a neutral conductor, Rule 4.020 in Section 0. The ungrounded, unidentified conductor of a circuit must be marked in a color other than green, white, or gray. This conductor generally is called the hot conductor. You feel a shock if you hold this conductor and the grounded conductor at the same time, or touch this conductor and a grounded surface such as a water pipe at the same time. Neutral conductor. In all residential wiring, the grounded neutral conductor's insulation is white or natural gray. It may also be white with a colored stripe as permitted by Rule 4.024.2. The grounded circuit conductor is also called a neutral conductor when it is part of a multi-wire branch circuit. When a two-wire circuit is used, the white grounded circuit conductor is not truly a neutral conductor unless it is the conductor that carries only the unbalanced current from the other conductors, as in the case of multi-wire circuits of 3 or more conductors, Rule 4.004.3. It is the conductor where the voltage from every other conductor to it is equal under normal operating conditions. Therefore, the white grounded circuit conductor of a two-wire circuit is not really a neutral, even though many electricians refer to it as such. Color coding, cable wiring. Non-metallic sheathed cable, Romex, and armored cable, BX, are color-coded as follows. 2-wire. 1 black, hot phase conductor, 1 white, grounded identified conductor. 1 bare, bonding conductor. Or 1 black, hot phase conductor. 1 red, hot phase conductor. 1 bare, bonding conductor. 3-wire. 1 black, hot phase conductor. 1 white, grounded identified conductor. 1 red, hot phase conductor. 1 bare, bonding conductor, hot conductor 120 volts, grounded conductor, neutral. 4 wire. 1 black, hot phase conductor. 1 white, grounded identified conductor. 1 red, hot phase conductor. 1 blue, hot phase conductor. 1 bare, bonding conductor. Color coding, conduit wiring. When the installation is conduit, Rule 4.032.3 permits the electrician to use any of the above colors for the hot phase conductor except green, reserved for use as a bonding conductor only. White or gray, reserved for use as the grounded identified circuit conductor. Changing colors. Should it become necessary to change the actual color of the conductor to meet CEC requirements, the electrician may change the colors, as indicated in Table 6.1. For cable installations only, Rule 4.032 permits you to use the white conductor as a switch loop for switch drops, but states that the white conductor must feed the switch. Therefore, you must make up the connection so that the return conductor from the switch is a colored or unidentified conductor. When the connections are done in this way, the CEC does not require re-identification, but instead accepts the splices and attachment of the conductors to the terminals of the switch as adequate identification. Therefore, if a white wire is used in a way that makes it a hot conductor, such as in a switch circuit, it should be wired so that it is always hot. It should be the feed to the switch, never the return. Look at the figure, which illustrates re-identification where the white wire running from the octagon box to the switch box is a hot phase conductor. Although Rule 4.032 states that re-identification is not required. Some electrical inspectors may require that these white wires be rendered permanently unidentified to avoid any confusion. Acceptable is defined as acceptable to the authority enforcing this code. When using two-conductor non-metallic sheathed cable for applications that do not require an identified conductor other than switch lines, the authority enforcing the code may require the use of a cable that has a red conductor in place of the white. In residential applications, this would be for loads that operate at 240 volts, such as electric heaters and hot water tanks. This cable usually has a red jacket so that the inspection authority can easily identify it. Many electricians choose to use non-metallic sheathed cable with different colored jackets. For example, the 12 halves cable used for the 20 ampere T-slot receptacles may have a yellow jacket. Or the 14 halves cable used for the arc fault circuit interrupter, AFCI, protected circuit may have a blue jacket. Different colored cables for specific applications aid the electrician when the conductors are terminated in the panel, clearly identifying the ampacity and type of circuit breaker required. Toggle switches, rules 14.500 through 14.514. The most frequently used switch in lighting circuits is the toggle flush switch. When mounted in a flush device box, the switch is concealed in the wall with only the insulated handle or toggle protruding. This figure shows how switches and receptacles are weatherproofed. Toggle switch ratings. The Canadian Standards Association, CSA, classifies toggle switches for lighting circuits as general use switches. These switches are divided into 3 categories. Category 1 contains general use switches used to control AC or direct current (DC) circuits. Resistive loads not to exceed the ampere rating of the switch at rated voltage. Inductive loads not to exceed 1/2 the ampere rating of the switch at rated voltage. Tungsten filament lamp loads not to exceed the ampere rating of the switch at 125 volts when the switch is not marked with the letter T. A tungsten filament lamp draws a very high momentary inrush current at the instant the circuit is energized because the cold resistance of tungsten is very low. For instance, the cold resistance of a typical 100-watt lamp is about 9.5 ohms. This same lamp has a hot resistance of 144 ohms when operating at 100% of its rated voltage. Normal operating current would be I equally divided by R, 120 divided by 144 equals to 0.83 amperes. But maximum instantaneous inrush current could be as high as I equal to E div by R, 170 peak voltage divided by 9.5 equals 17.9 amperes. This inrush current drops off to normal operating current in about 6 cycles, 0.10 seconds. The contacts of T-rated switches are designed to handle these momentary high inrush currents. The AC/DC general use switch normally is not marked AC/DC. However, it is always marked with the current and voltage rating, such as 10A 125V or 5A 250VT. Rule 14.508b3. Category 2 contains those AC general use switches used to control alternating currents only. Resistive, inductive, and tungsten filament lamp loads not to exceed the ampere rating of the switch at 120 volts. Motor loads not to exceed 50% of the ampere rating of the switch at rated voltage, but not exceeding 2 horsepower. AC general use snap switches are marked AC only in addition to identifying their current and voltage ratings. A typical switch marking is 15 amperes, 120 to 277 volts AC. The 277 volt rating is required on 277/480 volt systems. Category 3 contains those 347 volt AC switches used to control AC loads only. Resistive and inductive loads not to exceed the ampere rating of the switch at 347 volts. In addition, the current rating shall not be less than 15 amperes, 347 volts. The switches are designed so they cannot be mounted in boxes for Category 1 and Category 2 switches. Their mounting holes are 6.4 mm farther apart than those in standard switches. If they are grouped or ganged in the same box, AC general use switches operating in circuits exceeding 300 volts to ground must have permanent barriers installed between them. A typical switch is 15 amperes, 347 volts. The 347 volt rating is required on 347/600 volt systems. Switches and devices rated at 347 volts will not be installed in dwelling units because the maximum allowable voltage is 150 volts to ground. Rule 2-110. Terminals of switches rated at 15 or 20 amperes, when marked COALR, are suitable for use with aluminum, copper, and copper-clad aluminum conductors. Switches not marked COALR are suitable for use with copper and copper-clad conductors only. Screwless pressure terminals of the conductor push-in type may be used with copper and copper-clad aluminum conductors only. These push-in type terminals are not permitted for use with ordinary aluminum conductors. Rule 12-118-6. Further information on switch ratings is given in Rule 14.508 and in CSA Standard C22.2 number 111, General Use Switches. Table 5.2 in Unit 5 lists the markings on wiring devices indicating the types of conductors for which the devices are used. Toggle switch types. Toggle switches are available in 4 types: single pole, 3-way, 4-way, and double pole. Single pole switch. A single pole switch is used when a light or group of lights or other load is to be controlled from one switching point. The switch is identified by its 2 terminals and the toggle marked on/off. The single pole switch is connected in series with the ungrounded or hot wire feeding the load. This figure shows a single pole switch controlling a light from one switching point. The 120 volt source feeds directly through the switch location. The identified white wire continues directly to the load, and the unidentified black wire is broken at the single pole switch. In this figure, the 120 volt source feeds the light outlet directly, and a 3-wire cable with black and red wires is used as a switch loop between the light outlet and the single pole switch. Rule 4022-2 requires that the identified conductor be installed at each location of a manual or automatic control device for the control of permanently installed luminaires at a branch circuit outlet. This figure shows another application of a single-pole switch. The feed is at the switch that controls the light outlet. The receptacle outlet is independent of the switch. Three-way switch. The term three-way is somewhat misleading, since a three-way switch is used to control a light from two locations. A three-way switch has one terminal to which the internal switch mechanism is always connected. This terminal is called the common terminal. The two other terminals are called the traveler wire terminals. The switching mechanism alternately switches between the common terminal and either one of the traveler terminals. This figure shows the two positions of the three-way switch, which is actually a single-pole, double-throw switch. A three-way switch differs from a single-pole switch in that the three-way switch does not have an on or OFF position. Thus, the switch handle does not have on-off markings and cannot be used as a disconnecting means. Rule 2304-2. The three-way switch can be identified further by its three terminals. The common terminal is darker in color than the two traveler wire terminals, which are usually natural brass in color. Three-way switch control with feed-it switch. Three-way switches are used when a load is to be controlled from two different switching points. This figure shows how two three-way switches are used. Note that the feed is at the first switch control point. Three-way switch control with feed-it light. The circuit in this figure uses three-way switch control with the feed at the light. For this circuit, the white wire in the cable must be used as part of the three-way switch loop. The unidentified or black wire is used as the return wire to the light outlet. Rule 4030-2. This exception makes it unnecessary to paint, tape, or otherwise re-identify the white wire at the switch location when wiring single-pole, three-way, or four-way switch loops. Alternative configuration for three-way switch control with feed at the light. This figure shows another arrangement of components in a three-way switch circuit. The feed is at the light with cable runs from the ceiling outlet to each of the three-way switch control points located on either side of the light outlet. Three-way switches are needed in rooms that have entry from more than one location. In this residence, the garage lighting, entry hall lighting, living room receptacle outlets, rear outdoor lighting located between the living room sliding doors and the kitchen sliding doors, and receptacle outlets in the study require three-way switches. Conductor color coding for switch connections. The color coding for the travelers, messenger, for three-way and four-way switch connections when using cable can vary. Rule 30-600 requires that the white, identified, conductor always be connected to the white, silver, terminal of a lamp holder or receptacle. Because of the many ways that three-way or four-way switches can be connected, the choice of colors to use for the travelers is left to the electrician. Most electrical contractors and electricians establish some sort of color coding that works well for them. One option is to establish black and red for the travelers and make up the electrical splices accordingly. This is not a CEC requirement. This figure shows another option. The white conductor is spliced straight through to the lamp holder. The black and red are the travelers. This issue does not arise when using conduit, because a variety of conductor insulation colors exist for the travelers and switch returns. You cannot use white here for travelers. Four-way switch. The four-way switch is constructed so that the switching contacts can alternate their positions. The four-way switch has two positions, but neither is on or OFF. This switch can be readily identified by its four terminals and the absence of on or off markings. Four-way switches are used when a load must be controlled from more than two switching points. To do this, three-way switches are connected to the source and to the load. The switches at all other control points, however, must be four-way switches. This figure shows how a lamp can be controlled from any one of three switching points. Take care in connecting the traveler wires to the proper terminals of the four-way switch. The two traveler wires from one three-way switch are connected to the two terminals on the top of the four-way switch, and the other two traveler wires from the second three-way switch are connected to the two terminals on the bottom of the four-way switch. Some four-way switches have the connections from side to side on the switch. Traveler screws are brass and silver color for paired connection. The electrician must verify this using a continuity tester before connecting the switch. Take care when installing the flat-type four-way switches, generally known as Decora or Designer. Many of these switches use a different terminal connection layout than a toggle-type four-way switch. Check the packaging or use a continuity tester to verify connections before installing. Double-pole switch. A double-pole or two-pole switch may be used when two separate circuits must be controlled with one switch. A double-pole switch may also be used to provide a double-pole disconnecting means for a 240-volt load. Double-pole toggle switches are not commonly used in residential work. Double-pole disconnect switches, however, are used quite often in residences for the furnace, water pump motors, and other 240-volt circuits. Switches with pilot lights. Sometimes a pilot light is desired at the switch location, as is the case for the attic lighting in this residence. Pilot light switches are available in several styles. In this style you see: in Part A, the switch is in the OFF position. The neon lamp in the handle of the switch glows, and the load is off. This is a series circuit. The neon lamp has extremely high resistance. In a series circuit, voltage divides proportionally to the resistance. Therefore, the neon lamp sees line voltage, 120 volts, for all practical purposes, and the load sees 0 voltage. The neon lamp glows. In Part B, the switch is in the on position. The neon lamp is shunted out and therefore has 0 voltage across it, so the neon lamp does not glow. Full voltage is supplied to the load. This type of switch might be referred to as a locator because it glows when the load is off and does not glow when the load is on. In this style you see a true pilot light. The pilot lamp is an integral part of the switch. When the load is turned on, the pilot light is also on. When the load is turned off, the pilot light is also off. This switch has 3 terminals because it requires a grounded neutral circuit conductor. In this style you see this pilot light switch is a true pilot light. The pilot light is on when the load is on and is off when the load is off. This is possible through its internal electronic circuit. This type of switch can be used on any 120-volt AC grounded electrical circuit. It uses the system's equipment ground as its reference to permit the pilot light to glow. It does not require a grounded neutral conductor. The pilot light pulsates about 60 times per minute. Bonding at receptacles. Ground fault protection is covered in detail in Unit 9. However, providing bonding of the equipment, bonding of the conductor to a metal box, and to the receptacle's bonding terminal is important. To wire bonding type receptacles with armored cable, the cable must contain a separate bonding connector to bond the metal outlet box and the bonding terminal of the receptacle. If non-metallic sheath cable is used, it too must contain a separate bonding conductor, Rule 10-606. This figure shows the bonding conductor of non-metallic sheath cable attached to the receptacle, Rule 10-612. Almost all bonding terminals of the type shown in the figure are bonded to the metal yoke of the receptacle. However, this connection might not provide reliable continuity between a bonded outlet box and the bonding circuit of the receptacle. An outlet box is said to be bonded when it is connected to a bonding conductor that is part of a cable, or when it is connected to a bonded metal raceway, Rule 10-612. When the receptacle is fastened to a bonded device box, the bonding terminal may well be bonded through the threads of the 6x32 mounting screws. For a 102 mm square outlet box, Bonding to the raised cover could take place through the threads of the 8 by 32 cover mounting screws. However, it is doubtful that the continuity of the bonding circuit is reliable under these conditions. Therefore, Rule 10-612 requires the installation of a separate bonding jumper between all receptacles and the device box bonding connection. Whatever wiring method is used, metal conduit, armored cable, or non-metallic sheathed cable with a bonding conductor. The metal outlet box must be bonded in addition to using the bonding terminal of the receptacle. A bonding jumper is required between all receptacles and the device box bonding connection, Rule 10-612. The 6 by 32 mounting screws of most receptacles and switches are held captive in the yoke by a small fiber or cardboard washer. Removing this washer gives additional metal-to-metal contact. However, this is not adequate as a bonding means. Some outlet and switchbox manufacturers use washer head screws so that a bonding conductor can be placed under them. This method is useful for installing armored cable or non-metallic sheathed cable, as it provides a means to terminate the bonding conductor in the metal outlet or switch box. To ensure the continuity of the equipment bonding conductor path, Rule 10-612 requires that when more than one bonding conductor enters a box, they shall be secured under bonding screws or connected using solderless connectors. Splices shall not depend on solder, Rule 10-612. The splicing must be done so that if a receptacle or other wiring device is removed, the continuity of the equipment bonding path shall not be interrupted, as clearly shown in these figures. When wiring with non-metallic sheathed cable, the equipment bonding conductor is a non-insulated, bare conductor. When wiring with conduit, an equipment bonding conductor, when required, must be a green insulated conductor, sized per Table 16. Rule 10-612-5 states that the bonding jumper must be secured to every metal box even if the receptacle has a special self-bonding strap. Rule 10-612-6 specifies that when you install such a receptacle, you must wire a bonding jumper from the receptacle to the bonded outlet box in such a manner that disconnection. Rule 10-612-6 specifies that when you install such a receptacle, you must wire a bonding jumper from the receptacle to the bonded outlet box in such a manner that disconnection or removal of the receptacle will not interrupt the grounding continuity. Non-bonding type receptacles. Modern appliances and portable handheld tools have a 3-wire cord and a 3-wire bonding type attachment plug cap. Frequently, these tools and appliances are plugged into non-bonding type receptacles with only 2 prongs. In these circumstances, the appliance is not bonded and the user has probably cut off or bent the grounding prong to use the appliance. This is an incorrect and unsafe practice. As a result, it will later be impossible to bond the appliance even when it is plugged into a properly connected 3-wire bonding type receptacle. These circumstances require 2 methods of connection: the use of double insulated tools and appliances, the use of a portable double insulated ground fault circuit interrupter (GFCI) receptacle to supply the equipment. In neither case is the equipment bonded to ground. In many cases, it may be necessary to replace existing non-bonding type receptacles due to damage, or because a 3-wire bonding type attachment plug is to be used. A bonding type receptacle may be used if the receptacle is bonded to ground by one of these methods. If the device box is bonded, attach a bonding conductor from the device to the device box. Bond the receptacle to the system grounding conductor with a separate bonding conductor, Rule 26-702-1b. Connect to a metal cable sheath or raceway that is bonded to ground, Rule 26-702-1a. Bond the device to a metal cold water line, Rule 26-702-1c. If it is not possible to use one of these methods, the new receptacle can be protected by a Class A type GFCI breaker, Class A type GFCI receptacle, or connection to the load side of a feed through a Class A type GFCI receptacle, Rule 26-702-2. Induction heating. When AC circuits are run in metal raceways or trenches and through openings in metal boxes, the circuiting must be arranged to prevent induction heating of the metal, Rule 12-904-1. This means that the conductors of a given circuit must be arranged so that the magnetic flux surrounding each conductor will cancel that of the others. In this figure you see that to reduce the inductive effects as in previous figure, a plate of aluminum or other non-magnetic metal should be used, Rule 4008 and Appendix B. This also means that when individual conductors of the same circuit are run in trenches, they should be kept together, not spaced far apart, Rule 12-012-4. Tamper-resistant receptacles. Tamper-resistant receptacles are designed to minimize the occurrence of electrical shock and arc flash incidents that occur when conductive objects are inserted into the receptacle slots. Most of these incidents take place in homes. So, tamper-resistant receptacles were designed to prevent contact with live electrical components when an object is inserted into one of the receptacle slots. In one manufactured design, the slots for the ungrounded, live, conductor and the grounded, identified, conductor are closed by shutters that must open simultaneously. By inserting simultaneous pressure from the two blades of the plug cap equally against each shutter, the shutters will open. CEC Rule 26-706 specifies that, in a dwelling, unless a receptacle is rendered inaccessible or is located more than 2 meters above the floor or finished grade, all receptacles of CSA configuration 5-15R and 5-20R shall be tamper-resistant receptacles and shall be so marked.